Bismillahirrahmanirrahim. Assalamu alaikum student. How are you? I hope you will be fine. Today our topic is about group, and group is basically the level of intermediate or as well as A level. So the definition of group is a non-empty set. Let's say we say that G, name as G, a non-empty set G is said to be group. Is said to be group if it holds following axioms or properties. These are the main things to follow the definition of group: properties or axioms. So we can say that from this definition the every group is a set, because in definition a non-empty set G is said to be group if it holds following axioms or properties, and these axioms are: the number one is clear property. Its name derived from closed, and closed is known as we take one example, but in journal form, let for all. This is a Greek word for all. For all AB are two elements. For example, belongs to. This is a word name as belongs to. Structure of discrete mathematics. This is your word for all. This is belongs to. Here we use its whenever. This is the word such that. So instead of using these words, we prefer these wording because we doing a pure mathematics subject. So AB belongs to this set G such that A under any binary operation belongs to G. What is binary operation? Here binary operation is steric. Binary operation is steric. So the dear students, steric stands for here addition, multiplication, division, subtraction. In case of function, it is also as a compositions, and the case of matrices, multiplication, usual multiplication, etc. So A steric B, whether the steric is addition, so A plus B must be a one element and it must be belongs to G. Then we can say that the following set holds the clear property. Let me take an example. As we have a well-known set, the set of integers. Integer set can be written in this form: tabular 0, 1, 2, 3 up to so forth. So here the students, it will helps you to understand the clear property. So we take here any two elements, any of your choice. So we take A is equal to -3 and B is equal to 10. So addition, let me take steric is equal to addition. So here A plus B means -3 plus 10 is 7. Look, 7, is it belongs to integers or not? Yes, the answer is yes. So this is the meaning of clear property, means that you take the two elements from the understudy group. Here understudy group is set of integers. You took the two elements from set of integers, and under the given binary operation you operate these two elements with each other, and the answer is also from this set. So we can say that the set is closed. And now we move to the second one, is very main associative property. So the word associative means the combination, the chain. Here the chain in between the numbers, and the numbers in counting of 3. Let for all, I define it, let for all ABC belongs to G such that A steric bracket B steric C, A steric bracket close. So students, this is associative property equation. We took three elements, but no worry about association because it is we have a general result that any subset of real number should hold associative property. A real number is a big field, or any subset of a complex number should hold associative property. In every question we can write this statement as we know that the set of integers, for example, we also take the previous example which is in Collier property, -3, -2, -1, 0, 1, 2, 3 up to so forth. And if we want to prove the associative property, associativity, let for this purpose we take any three elements. For example, -11 and 9 and 100 belongs to integers. So now the binary operation is we take here also addition. You can take multiplication. So here is -11 plus 9 plus 100. So this number gives you a 109. 109 first of all. 109 minus 11 is your 98. So 98 obviously belongs to set of integers. Now we move to the right hand side, which is expressed in the first two numbers have a close bracket and the third one is individually. So we treat it first, -2 for 100 and you will get 98. So this answer you tell us about the information that these two left hand side and is equal to right hand side. So association property is hold in the set of integers under the binary operation addition. Now we move towards the very main property, and property is known as existence of additive identity. Additive identity means if we take a binary operation multiplication, so multiplicative identity, or generally we say that existence of identity element. You can say that as existence of identity element. So for this purpose their general form is let for all A belongs to G, all belongs to a G, every element of G for all means. Then there exists R. R means only one element, which is known as E belongs to G. E stands for identity. This E is 0 if is binary operation addition. This E is 1 if it is multiplication, and other than E is also 0 and 1 if according to the given set. So E belongs to G such that A steric E as well as E steric A, you will get A. So left hand identity, right hand identity, left hand identity give us the original element A. So for this purpose we take also example of integers -3, -2, -1, 0, 1, 2, 3 up to so forth. So for this purpose we take element, for example -3 belongs to G. So your observation is that only element which give us a back -3 and this element is 0, and we may better know that 0 is additive element, additive identity, and 1 is multiplicative identity. Now we move towards the, so we declare that 0 is additive identity. Now we move towards the multiplication. Moves towards the existence of the last property, existence of inverse element as well as additive inverse. You can say that in case of addition, in case of multiplication, it is multiplicative inverse. So by general rule, existence of inverse element. So how can we conclude that let for all A belongs to G, there exists a unique element corresponds to G minus A belongs to G, such that A steric minus in case of additive inverse, and 1 over a in case of multiplicative inverse. So we perform addition, so a plus minus a, and here plus stand for steric, and minus a plus a is give us a back to the identity element. This gives you a additive inverse. So we also take for the sake of betterment of understanding, we choose a example. Example is very famous: minus 3 minus 2 minus 1 0 1 2 3, and you look at the set of integers. If we take 1, it has additive inverse 1. If we take minus 3, it has additive inverse plus 3. If we take minus 5, it has additive inverse 5. Why? Because 1 addition minus 1 addition 1, you will get 0, as well as minus 5 addition 5 addition minus 5, you will get 0. What is 0? 0 is additive identity. Additive identity, when comes out on the operation of two numbers with each other, then we can declare that these twos are inverse of each other. 5 is additive inverse of minus 5, and minus 5 is additive inverse of 5. So here we conclude what we will get from this lecture. So a set G is group. Make a group under binary operation. Here addition, we took a addition, and if we took multiplication, then it is said to be a multiplication. So finally we have our remarks about lecture. A set, if it holds only Collier property and remaining properties or fail, not valid, then this set is known as groupoid. Its name as groupoid. And the set also hold a associative property along with Collier property. This is a priority order. So we can say that it is known as semi-group. This is a semi-group. And if we take three properties priority wise: identity element, if a set, any set, Collier, associative, identity, all three properties are hold, then this following set under study is known as monoid. And if the set, all the four properties hold, and with which are, last one is inverse element, then the set is known as group. So our today target is group, so we complete it. But dear student, I want to discuss with you that group has two different types, which is a finite and infinite. So in next class we will discuss finite group, and in the next class we will discuss infinite order group. So take care. Bye bye.